Now question 4. Express 0.999 recurring in the form of P upon Q. Let x is equal to 0.999. So this will be our equation number 1. Now how many digits are repeating here? So you can see that only one digit is repeating often and often. That is one digit. So you have to multiply both the sides by 10. Multiplying both the sides by 10. So 10x equal to 9.999 recurring. If you multiply 0.999 by 10, this point will move for one digit and it will come here 9.9. Now you have to subtract equation 1 from 2. Subtracting 1 from 2. 2x minus x. 9.999 minus 0. You will get 9x equal to 9. Take 9 on the other side. So x is equal to 9 upon 9. X is equal to 1. Question 5. What can be maximum number of digits be in the repeating block of the digits in the decimal expansion of 1 upon 7? Means you have to divide 1 by 17. Perform the division to check your answer. So if we divide 1 by 17, 1 divided by 17, so put as many as zeros you require and carry on the regular division. So 1 is less than 17, so put 0. Put decimal point, put another 0. Again 10 is less than 17, so put 0. Bring another 0, that is 100. So 17 5s are 85. 15 remainder, bring down 0. 17 8s are 136. 150 minus 136, you will get 14. Bring down another 0. 17 8s are 136, 4 remain. Bring down one more 0. 17 2s are 34, remainder is 6. In this way you can continue up to you get the recurring number. So if we go on continuing this division, you will get 0.015882352941176647. Again the same number will go on repeating. So you can see that there will be 16 digits after the decimal point. Question 6. Look at the several examples of rational numbers in the form of P upon Q. So we have seen several examples of rational number in the form of P upon Q, where Q is not equal to 0. Where P and Q are integers with no common factor other than 1. They have only common factor 1 and having terminating decimal representation. Can you guess at what property Q must satisfy? So in the form of P upon Q. So for rational number, what must be the property of Q? So if you have seen in all the example, Q is always either 2 or the power of 2 or 5 or power of 5 or both. If you see any rational number, denominator will be in the form of 2 or 5 or both or power of 2 and 5. The prime factorization of Q has only powers 2 or power of 5 or both. So that property of Q can only be the rational number. Question 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. Means it should not be terminating. Non-terminating and non-recurring. Non-recurring means same number should not be repeated again and again. Same number should not be repeated again and again. So there are infinite numbers. So you can write any number which is non-terminating, non-recurring. As for example, if you write 0.01, 001, 001, 0001, so here you can see that no digit is repeating often and often. Different digits are repeating. So this is said to be non-terminating, non-recurring. Another example you can take 0.2, 02, 002, 0002. Here also you can see that no digit is repeating often and often. One more example 0.003, 0003, 00003. So in all these three examples, you can see that none of the digit is repeating. No digit is occurring often and often. So all these are the examples of non-terminating, non-recurring. Question 8. Find three different irrational numbers between the rational number 5/7 and 9/7. So 5/7 and 9/7 are rational numbers. Between these two, you have to find out irrational numbers. So first you have to convert 5/7 and 9/11 in the decimal form. So 5/7 can be written as 0.714285 infinite. 9/11 can be written as 0.818181. So our required number will be between 0.71 and 0.81. So there are infinite numbers. There are infinite numbers between these two decimal expressions. So you can take any three as we are asked 3. So irrational numbers between 5/7 and 9/11 are 0.750, 7500, 75000 like this. You can see that no digit is repeating often and often. So this number is said to be irrational number. In the same way, 7670, 76700, 76700, here also no digit is repeating often and often. So this is also irrational number. Third required number you can write 0.80, 800, 800, infinite number. All these three numbers lie between 0.7 and 0.8. So these are the three required irrational numbers which lie between 5/7 and 9/11. Question 9. Classify the following numbers as rational or irrational. So here few numbers are given. You have to decide whether it is a rational or irrational. For that you have to remember the definitions of rational and irrational. So earlier we have studied rational number means those which can be expressed in the form of terminating or non-terminating recurring. Rational number can be expressed in terminating decimal expression or non-terminating but recurring decimal expression. And those who cannot express in this means those who can express in non-terminating, non-recurring. Non-terminating, non-recurring will be irrational number. So root 23. So root 23 cannot be expressed in the form of terminating or non-terminating recurring. So root 23 is irrational number. In other way, you can remember you don't know exactly the root of 23. So root 23 will be irrational. Second one is root 225. So you know that root of 225 is 15. You can find out the root of 225. That is 15. So root 225 is rational. Third one is 0.3796. 0.3796. So which type of decimal form is this? This is terminating decimal point. So terminating decimal form is a rational. So 0.3796 is a rational. 7.478478 recurring. Here you can see that same number is recurring often in F1. 478, 478, 478. So this type of number is said to be non-terminating recurring. Non-terminating recurring. So it will be also rational. Now fifth one. 1.10, 100, 100, like that. So here same digit is not repeating. Same digit is not repeating. So it is irrational number. Now exercise 1.4. Question 1. Visualize 3.765 on the number line using successive magnification. You know magnification. Magnification means enlargement. So as it is 4 digits, you will draw 4 lines. So first of all, you have to decide between which two integer 3.765 lie. Between which two integers 3.765 lie. So you know that 3.765 lie between 3 and 4. 3.675 lie between 3 and 4. Now you have to magnify. You have to enlarge the digits between 3 and 4. So between 3 and 4 you will get 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and 4. Now for second digit, that is 3.7. So you have to decide between which two this number 3.765 lie. Between which two number 3.765 lie. So you can understand that 3.765 will lie between 3.7 and 3.8. 3.675 will lie between 3.7 and 3.8. Now you have to enlarge, magnify 3.7 to 3.8. So that can be magnified in the manner like this. 3.7, 3.71, 3.72, 3.73, 3.74, 3.75, 3.76, 3.77, 3.78, 3.79, 3.8. Now again for fourth digit, 3.765 will lie between which of these two numbers? So you can understand that 765. So this 5 will lie between 3.67 and 3.77. 3.765 will lie between 3.76 and 3.77. So again enlarge this. Enlarge the region between 3.76 and 3.77. Magnify it. So by magnifying it, again you will get 3.76, 3.761, 3.762, 3.763, 3.764, 3.765, 3.766, 3.767, 3.768, 3.769, 3.77. So on this number line, this our required number will lie. So you can see that 3.765 lie here on the number line. On the number line, it will lie here 3.765. So in this way, you can represent the given number on a number line. Visualize 4.26 recurring 2626 on the number line up to 4 decimal places. After decimal point there must be 4 digits. So 4.26 can be written as 4.2626. Now we have to represent this on the number line. So first of all you have to decide where 4.26 will lie. So you can understand that 4.26 will lie between 4 and 5. 4.26 will lie between 4 and 5. So now you have to enlarge region between 4 and 5. Magnify. So region between 4 and 5 will contain 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8, 4.9. Now again think, 4.26 will lie between which two numbers? 4.26 will lie between two numbers. So you can understand that 4.26 will lie between 4.2 and 4.3. 4.26 will lie between 4.2 and 4.3. Now enlarge it. Enlarge 4.2 and 4.3 by drawing this line. So number between 4.2 and 4.3 will be 4.21, 4.22, 4.23, 4.24, 4.25, 4.26, 4.27, 4.28, 4.29. Now again think 4.262. So 262 will lie between 4.26 and 4.27. 4.262 will lie between 4.2 and 4.27. Enlarge it. Magnify it. Again you have to find out 4.2626. 262 will lie between 4.6 and 4.27. 4.261, 4.262, 4.263, 4.264, 4.265, 4.266, 4.267, 4.268, 4.269 and 4.27. Now last digit 6. So where this 4.2626 will lie? So it will lie between 4.26 to 262, 4.262 and 4.263. So this number 4.2626 will lie between 4.262 and 4.263. Now magnify it. So number between 4.262 and 263 will be 4.2621, 4.2622, 4.2623, 4.2624, 4.2625, 4.2626, 4.2627, 4.2628, 4.2629. So here will be our required number 4.2626. So 4.2626 will lie here. 2625, 2627. So this is 4.2626, which is in short written as 4.26 bar. So this is our required answer. Now we will start exercise 1.5. Question 1 is classify the following numbers as rational or irrational. So you have to find out which numbers are rational and which are irrational. First one is 2 minus root 5. You know that root 5 is irrational. you cannot find out the root of 5. So 2 minus root 5 will be an irrational number. Second, 3 plus root 23 minus root 23. So plus root 23 and minus root 23 will cancel and you will get only 3. 3 is a rational number. So 3 plus root 23 minus root 23 will be a rational number. Third, 2 root 7 upon 7 root 7. Root 7 and root 7 will cancel. You will get 2 upon 7. 2 upon 7 is a rational number. So 2 root 7 upon 7 root 7 is a rational number. Fourth one, 1 upon root 2. You know that we cannot find out the root of 2. So root 2 is irrational number. So 1 upon root 2 is also an irrational number. Fifth, 2 pi. Pi is an irrational number. You know the value of pi. So 2 pi will be an irrational number. Question 2. Simplify each of the following expression. Now here you have to simplify this expression using the unique identity. First one is 3 plus root 3 into another bracket 2 plus root 2. So you have studied this formula in the previous standard. A plus B, C plus D. So if you get such sum, you have to multiply this bracket by A and again by B. So you will get AC plus AD plus BC plus BD. So here first 3 into the whole bracket 2 plus root 2 plus root 3 into 2 plus root 2. Remove this bracket. 3 2s are 6. 3 into root 2. Root 3 into 2 means 2 root 3. Root 3 into root 2. 6 remains as it is. 3 root 2, 2 root 3. Root 2 into root 3 will give you 6. So answer is 6 plus 3 root 2 plus 2 root 3 plus root 6. So this is the simplified form of 3 plus root 3 into 2 plus root 2. Question 2. 3 plus root 3, 3 minus root 3. So here you can see that both the numbers are same, 3 and root 3. Only difference is that here it is plus and here it is minus. So you have to use this formula A plus B, A minus B. This formula also you have studied in previous standard. A plus B into A minus B gives you a square minus B square. So here also 3 plus root 3 into 3 minus root 3 gives you 3 square minus root 3 square. 3 square is 9. Root 3 square is 3. 9 minus 3 equal to 6. So simplified form of 3 plus root 3, 3 minus root 3 is 6. Answer. Now third question. Root 5 plus root 2 whole square. For that you have to use this formula which you have studied earlier. A plus B whole square. You know the formula A plus B whole square. A plus B whole square is equal to A square plus 2AB plus B square. Apply this formula here. Root 5. Instead of A you have root 5. Instead of B you have root 2. So root 5 square plus 2AB means 2 into root 5 into root 2 plus B square. So root 2 no square. Root 5 whole square gives you 5. 2 as it is. Root 5 into root 2. 5 2s are 10. Root 2 square is equal to 2. Now 5 plus 2 can be added. Simplify this. 5 plus 2 7. 2 root 10 remains as it is. So answer is 7 plus 2 root 10. Now fourth one. Root 5 minus root 2 into another bracket root 5 plus root 2. Though this is similar to the formula A plus B, A minus B. So you know the formula A plus B, A minus B gives you A square minus B square. The root 5 square minus root 2 square. Root 5 square gives you 5. Root 2 square gives you 2. 5 minus 2 is equal to 3. So 3 is the answer.